Oh no, starting
It's
soon.
happening.
Starting soon.
Who's on that? Someone mute everything.
It's working over there.
I don't believe it. Wait,
Is it happening? Is it working?
No, it's still not. Wait.
Oh!
It's not broadcasting here though.
Refresh.
Is it broadcasting on the other end?
It says it's live.
Sorry. Oh wait. I don't.
That's not bad.
I know.
Also says there are 0 viewers.
Yeah,
Yeah, something's wrong because they definitely are.
It's working over there.
This is.
See if you can change the bit stream.
I have that open too.
Nope.
It's working over there. Good at this. It's fun.
Now we're
No,
behind
Good
the scenes.
下巴 one. Except. Okay. Oh. Welcome to you.
There we go.
Okay.
Yeah. We're live, folks. We're live.
Oh, we are.
Yeah.
Oh, we are.
Well, that's delayed.
I mean, it's gonna be late, yeah.
Push to talk. What does that do?
All right, so go ahead, Sammy. All right, this is the camera one.
Are there
All right, I'm gonna take it with me.
Mine is just behind the scenes.
Right.
What's going on?
Okay. Yeah, let's see.
So,
Actually, you know what?
maybe
we'll just put this like.
No, I don't know.
All right. Let's hopefully that is that backwards. Is everything?
I don't know yet.
I don't know.
Wait, let's see. Is it?
I think
No, it's
everything.
right.
It is.
No, we're good. No. I
It,
can't
it should be just like
Should be good.
Oh God, he's coming right towards us.
Entry's gonna be like
Wait a minute.
Watching you guys debug is very.
No, it's the right way. I'm watching Sammy watch you guys debug.
It's the right way.
Okay, yeah, it works. Sweet. Well, shit. I don't know that I can't. Yeah, I
I
can't.
love
All
that
right, Elliot's
we're all
got it.
sitting here watching it on YouTube.
You're all in the room with me. Hello and welcome
Hello.
to Design to Prototype. Well, I forgot what I called it. A lesson in making awesome things. All right. Well, this is weird. I have to like run over here.
Would somebody like to man
Yeah, well,
the
someone.
next
Yeah, well,
one?
someone.
Here, I got it.
Oh,
Go on.
Oh, sniped.
Oh no.
So for those of you watching the stream, you guys, I think, outnumber the people in this room. That being said, all of you already know pretty much everything that's in this slide, in this presentation. So just, I guess, enjoy the awkwardness of me standing in front of this computer and kind of reading to you guys. All right. That being said, say you have a problem, right? Bartending's messy. It's time consuming. You have people over. What do you want to do? You want to make them drinks. You want to get everybody drunk and you want it to be a happy occasion. But you can't. You don't have enough time, right? Say you have no car and you want to get to your buddy's house. You want to get to the grocery store. And there's no way to get there other than to take some motorized vehicle, right? Or maybe music is fantastic on its own, but a light show would be that much cooler. So what do? You have 3 options. You can buy something that might solve your problem. You can have someone else try and solve your problem for you, or you can do the right thing and fix it yourself. All right, so here, really quick, right? We have an automated bartender. We have our motor pack to get us around town. And we have a little circuit over here to perform a light show while we listen to our music. Yeah, I know. I really wish I had one. Oh, wait, you know what? Give me the mouse.
All right.
Hopefully this works. Yes. Okay. So, but how? So really I broke it down into 3 major steps. First being kind of this design phase. The second being ordering of your parts because, well, I had intended this presentation to be for people who hadn't taken senior design, who had never really built any projects on their own. The idea was to get Tech Collective members involved in making their own projects so that Brandon and Mark wouldn't have to keep doing it over and over and over by themselves. But
We're old and tired.
they're old and tired. Anyway, so again, and then the last step being the actual build of the prototype and what you should do while you're going about it. So first and foremost, the design phase. And I broke this into 4 separate sections. First being research, followed by your kind of flow charts and diagrams and stuff like that. Then your circuit diagrams, and finally, if you're going to do anything mechanical, maybe your CAD along there with it. So I want to go into the research first. And in this particular instance, the most important thing about the research is, 1, it is continuous. You do not stop throughout the whole project. It's going to continue to occur. And 2, I really want you to learn to kind of find your own, solutions. I don't want this to be just me handing everything to you. I think this is like awkwardly in the way of all the lettering on the stream.
I feel like I'm watching hackers.
Yeah. Here's what we're gonna do. Maybe we can let's just move this a little bit further back so I can kind of stand off to the side. Yeah, that's the good stuff.
Beautiful.
I'll let you know in a few minutes when I see it over here.
Yeah.
All right. So, say you want to do your research, but where do you go? What do you do? Right? I mean, you can't just magically have all these tomes in front of you with everything you need to know. But what I've kind of gone about, in my life, I kind of start with these first 3. If I can find a solution, kind of quickly there, that's the best. Other than that, I can kind of go about and ask other people. But again, Google images. Just Google your problem and then see if you can. More often than not, the first 2 or 3 images on Google Images will be your solution. Other than that, you can always go back and read up on anything you may need to do. Wikipedia, obviously, and then another great resource are kind of these 3 subreddits. Our ECE and our Ask Electronics tend to be fantastic, especially our Ask Electronics. You can kind of tag your posts as whether it's a design question or a build question or whatever it may be, and people get back to you relatively quickly with potential solutions that you may ask. And then the last one being you can ask old professors, friends, colleagues, whatever it may be. They may have some insight for you. So now we'll move on to flowcharts. And why do I like the idea of flowcharts for going about a project is mostly because it helps you kind of modularize your project. You can break it down into small, bite-sized pieces, each one and you can tackle each one individually and then kind of see how they all fit together, right? And then the last part that happens more often than not with me, at least, is it helps to minimize redundancies. So more often than not, I have like 2 parts of the same project doing the same thing, and after I've kind of laid it all out in the flowchart and everything, I'm like, oh wait, I can just get rid of this right here. So just a quick example of one that I had done a couple years back was this is for a ECG monitor algorithm that basically took the electrocardiogram, your heart rate signal and whatnot, and from there it would determine whether or not your heart was healthy based on how quickly your heart rate changes over time, right? So not necessarily looking at just whether your heart rate sped up or not, but how often your heart rate sped up over a course of time, up and down. And so a healthy heart is very easy to adjust. You can go from a normal 80 BPM to up to 150 in 10 minutes of exercise and then drop back down. But an unhealthy heart may struggle a little more, so you may end up taking a lot longer to get up to that higher heart rate and a lot longer to come back down. Or another instance, maybe if a person is septic, if they have a whole body infection in the hospital, what you end up seeing is more often than not, the heart rate is elevated just to begin with. So you have people sitting around 110, 120 BPM with infections. And because of that, the cap stays around 150. So there's a lot less variability in what they can have within their heart rate. And this algorithm kind of here, just again, flow chart, the idea being, first it takes, this ECG signal, and then you can kind of look and say, oh, I need to filter it, and then I need to compare some values, and so on and so forth. But in the end, this kind of helped me put together all the code nice and neatly, in several different functions, and that allowed me to put together this whole project pretty quickly in the end. The next piece for all you ECEs out there, circuit diagrams. This one right here may or may not look familiar to some people. It's the original all of the lights circuit diagram. And so here, this is the audio input. You have your two filters right here. Eventually, this is your solid state relay. And then this section over here is kind of just your input, not your input, your power source. So this could be, your 120 hertz, or your 120 volt, 60 hertz wall plug and whatnot. And the last part is if you're doing something a little bit more involved that requires, some casings or potentially some mechanical devices to be involved with it, it may be helpful to go ahead and learn to use, a CAD software of some sort. So you can actually draw up all these drawings, take it to the machine shop, and have something. So this right here is one of the earlier versions of the fourth Carlos's carousel. So each one of these holes right here holds a different cup, and then there's a big tower in the middle that houses all of the alcohol and whatnot. And this carousel moves around the tower and puts your cup under each, bottle, whatever it may be. But again, this was, mocked up real quick. The idea being I could go ahead and take it to, a 3D printer, take it to a machine shop, whatever it may be, and I could get, a physical piece in my hands. So this is, again, meant for people who may have questions. I don't know if you guys actually have questions. Yeah, Elliot.
So I sort of get the flow of progress through the project, but obviously when you're doing research, maybe when you're first assigned the project or the problem or whatever, maybe even before you start the research or as you're going through the research and you have all these ideas of how you're going to tackle it, how do you sort of manage all those ideas? Do you just make a list of things?
So typically what I do is the reason I put research first is just it's kind of the most important to me of all of these. But the first thing I really do usually is I make a flow chart, right? I have all these ideas, and so I start jotting down notes on paper. And eventually, once I have kind of all my ideas down on paper, I start rearranging them into a big flow chart, right? And then say I get to a section of this flow chart where it says, oh, I need to filter this, or oh, I need this to run X amount of iterations, and so on and so forth. And I think to myself, oh, I don't really know exactly how to do this or what the right, if there's a more efficient way to do this, blah, blah, blah. Then I can go and look up that exact kind of terminology that I have in my flow chart, or I can look up something similar. So again, like with the filter, say, I normally am using like a first order filter just for, get rid of certain frequencies. And I'm thinking to myself, oh, this is great and all, but really I could use, a higher order filter. Well, that would be a point in the project where I would go then and research, higher order filters and kind of proper designs of them and so on and so forth. Does that kind of answer your question?
Yeah.
Okay. Any others before I move on?
Ben Yarmus would like to know, what is your Reddit username?
Ben Yarmus, you may not know my Reddit username.
I know his. It's Diabetes Man.
Now that might be Dan Catan. Yeah, it could be. I guess that's true.
No, it's definitely Armis.
Is it? Oh, sneaky. Anyway, moving on. The next part is, this was kind of intended to be the meat of the presentation for the people that were supposed to be here. People who haven't done senior design and don't really know what the hell they're doing. Ordering parts, because as much as, it's kind of second nature to people who have done it, once or twice before, it's extremely overwhelming the first and second time you do it, right? You go and you're trying to find all these websites that have all these parts and so on and so forth, and you go onto digikey.com and whatever, and you look up op amp, and there are 36,000 options of op amps, and you're like, what the hell am I doing, right? So I wanted to go through this and kind of just give you kind of three, ideas, right? First being, finding the right part is overwhelming. How do we go about finding the right part? The second part being kind of navigating these sites and so on and so forth. And the last part is it really worth it to buy the part that you just found, right? And I'll come back to why in a second. So say you're looking for the right part, you're trying to find the right part. And what does that mean? It means you need to figure out, one, what is the part intended to do in this project? And two, why are you specifically looking for those kind of specifications from the part? So say you want an op amp, like going back to our earlier example. You may want an op amp that has a certain amount of gain. You may want it to work in certain frequency ranges. And then you need to figure out kind of what package type you want for this particular piece. Is it something that you want it to be a through-hole piece, or do you want it to be a surface mount piece, and so on and so forth. And so again, here, op amps, right? You click on op amps and literally 36,000 different types. And you come here to DigiKey and you're like, oh man, what do I do? I can have I can set my slew rate. I can check my gain bandwidth, my -3 dB bandwidth, so on and so forth. I can look at my bias current and things like that. But if you've never really done this before and you're kind of just venturing into this for the first time, it may be a little overwhelming to try and find exactly what you need. Or the other scenario being you found exactly what you need, but it's like $500. Well, no one's going to go and spend $500 for an op amp that they may or may not use in this prototype, right? So the next kind of idea being, is it really worth it to spend $300 on something you need exactly, or maybe be more beneficial to buy something that's $5 that's a little bit more general, but it kind of fits within your specifications, right? So I kind of pulled up an example here, right? This is an AD620, which is a bioinstrumentation amplifier. It's $8.38. Right next to it over here is the AD522, also a bioinstrumentation amplifier. The difference being one of them is $335, while the other is $8. Right? And if you're looking at this, you're like, well, what's the big difference? Like, why would I really care about this? Well, one of the biggest differences is kind of the, where is it? The input bias current, right? So this one over here, you have, this one's in, or was it? No, I take it back, sorry. It was the supply current, right? This one over here, 8 milliamps, this one over here, 900 microamps. But if you look at the slew rate, this one, you get 1.2 volts per microsecond. Over here, you're getting 0.1 volt per microsecond. So, in the end, it may be something that, the specifications that you need don't necessarily have to be, the specifications that you need don't necessarily have to be the exact piece that you find. You may be able to find something a little bit more general that works for you. So let's see. The next part was kind of, again, meant for people that would be here. The idea being, I can kind of give them some sources for where to look for parts, DigiKey, Mauser, McMaster-Carr, if you're doing anything that requires mechanical pieces. Amazon, eBay are all phenomenal for finding stuff a lot cheaper than you normally would on these others. And then the big one that people, for some reason, don't do are free samples. Free samples are the greatest thing ever. You can go and say there's like a $60 part that you want, and you don't want to actually go buy it. You just say to the company, hey, I'm building something really quick and I want to see if your part is the right fit. They say, okay, we'll send you some free samples. And they send you 2 or 3 of these things, and you may use them, you may not use them. But now you have 2 or 3 of these things for $180 worth of value just for free, right? Always check to see if you can get free samples from someone. Always. I think during my senior design, Dan Catan managed to pull out like $500 worth of stuff in free samples. So definitely look at free samples. And then the last part being, if you find something that is either too expensive or you can't find exactly what you need, this or the other, feel free to get creative. There are no kind of restrictions on what you can't do when it comes to parts, right? So, in one of the early versions of the Bartender, I literally went and I bought Snapples. And I use the Snapple bottles as my containers, my reservoirs, because I could go to, I could go on Amazon or McMaster or something and find, vacuum sealable bottles, but they're like $40, $50 a piece. I'm gonna go spend $40, $50 a piece. I'd rather spend $1.50, $2 on Snapple. And then again, there are things that had, I could find valves and stuff that had, all sorts of LEDs and crazy contraptions, things like that. It's not worth it. I found these guys, these little valves over here. They were, I think, $1.50, $2 also. I just connected up some LEDs to them. So anyway, that was the kind of the biggest chunk for the people that were supposed to be here. The last part being kind of the prototyping. And there are kind of 3 parts of that I want to go over. One being this, the idea of subsystems, the second being of iterations, and the last one being documentation. With subsystems, kind of the greatest thing about subsystems are you can put together something much smaller, test it, debug it, make sure it works before you integrate it into the overall system, right? So say you have, a whole bunch of like circuitry and electronics and stuff that you want to make sure works before you add it into everything. Or say you have, a whole bunch of kind of mechanical parts. So you have a whole bunch of valves and pumps and things, and you want to make sure that they actually do function the way you thought they were, going to function before you incorporate everything into one big project, right? So then everything works individually and so on and so forth, and it's all happy, and finally you get this jumble of wires and everything, but it's early first kind of generation prototype, which leads me to iterations. Always, or at least for me, I always find that going through 2, 3, 4, 5, 6, 7 versions of something leads to a nicer looking, a more elegant experience overall for something, right? So in this case, like the first bartender that you just saw was just kind of a jumble of wires and tubing and things like that, and it all dumped into one funnel, and it worked and it did its job, but it was kind of gross. End of the day, like you had to like clean out this funnel, and you pretty much had to clean it out after every drink, right? Because like it would make one drink, and then like there would like be remnants in this funnel. So you either had to flush the funnel with water, or you had to clean it out in between each use, which really defeated the whole purpose of the bartender being like this quick, efficient way of making a whole lot of drinks. Right? And so that led to other ideas like the CAD drawing you saw earlier with the carousel. And that way I could put a cup in each, spot and spin the cups around rather than funnel into one space. Anyway, so this is a kind of a good example of like the iteration idea. This was one project that I worked on over the summer. It was this skateboard motor pack type deal. And when I first started, I don't know if the people live streaming or not can see it, but there's like a wheel back here and like a big old 24 volt, I think it's 350 watt, motor right here. And in this, there are like 2 giant lead acid batteries, and like it was gross, right? But I did this. I kind of found what I needed to find in terms of the problems with it and so on and so forth. And that led me to kind of this next version, which cut down significantly on the size. If you can see, I have this giant box right here. The next one, this is like an old, I got this from a secondhand, so it's like an old Army medic box. But again, same thing, I now took kind of all the control electronics and everything that were in the big box, and now they're in this little box. And then next step, I managed to go even smaller. And then finally, after kind of getting it to this point where I have, wheel, motor, all the control electronics and everything right here, finally it ended up going into a backpack. And so right here, what you can see, this is literally just a backpack, and battery and control electronics and everything are inside it. And motor, wheel, whatever, it's very easy. You just kind of clip it onto the back of your skateboard, and you can just go. And with it, there's like a wireless glove that you make a fist, and that's what turns on your motor. And very easy to use. But it took me 5 or 6 generations of the same project to get to this point.
Emma asks, how does Sammy balance time and budget for iterating on the same project?
Yeah, so I don't know if you can tell, but this chunk of wood and motor and wheel do not change between all 3 or 4 versions. Okay, I mean, I literally use I reuse parts. So I mean, that's kind of the advantage of iterating with your own design, right? You know what worked and what didn't work, and so if something worked, just keep it. You iterate on things other than that. In terms of time management, I don't know. I mean, it's just like a hobby of mine. So whenever I was around at home doing nothing, I was like, oh, I might as well go work on this project. I guess in total time it took me to finish this project, I'd say 50 to 60 hours. And that was after 4 or 5 different iterations of it. And then the last part that I really wanted to kind of hammer into the people that were supposed to be here is the idea of documentation, because a lot of people don't do this, and it's essential for any project that you want to present or you want to come back to or anything of that note. And this right here, these are shout out to Emma. She took these back in the day. This was when we were first coming up with all the lights project. Ian Wilson, Emma, and I were kind of just sitting right outside of Tompkins. It was a beautiful day. So we took a soldering iron outside and had all of our parts and just started taking pictures and stuff. But I mean, here,
Looks safe.
yeah, it was on a metal table too. Nothing was grounded. We just went for it, you know. But you know, here again, so parts put on the board and kind of showing all the steps involved in making this to go along with your circuit diagram, your flow chart, your CAD models, whatever it may be. Putting it all together in kind of one unified space allows you to kind of go back and see what you did or didn't do. Anyway, so that was kind of the whole spiel. In the end, we ended up with kind of our design, the ordering of the parts, and the building of the prototype. Any questions? Easy. All right, how about you guys? I want to go get the lights.
Maybe a minute before they
Yeah.
catch up and have any questions.
That's not her.
Can I see what they're saying?
Underscore E.
Oh, that's awkward.
Are you sure it's underscore?
Yes.
Yeah.
Because I was able to just follow.
Oh, that's awkward.
Ben Yarmus wants to know, how do you teach yourself these things?
Yeah.
How do you teach yourself things?
How do I teach
Just caught
myself?
up. I don't, yeah, literally.
So that kind of goes back to the research chunk, right? I mean, the idea being if you have some sort of a problem, you know, or if you don't really know what you're doing, go and look it up. You know, you spend some time reading up on it or watching videos or talking to people about it. More often than not, I find it most useful to kind of just dive right in. So say I'm working on some coding project and I've never, you know, worked with this one language, or I'm, you know, tinkering around with some piece of electronic that I've never tinkered with before. You know, keep it with, especially with electronics, you got to keep it like within like safe ranges, but you can, you know, tinker around with it. You put it on a breadboard, see what it does. With coding, you know, go through a couple, you know, lines of code, go, you know, watch other people do the same thing, or, you know, read through other people's code and so on and so forth, and, you know, try and figure out what they're doing. But that's why I kind of put research first in that one category. It was, you know, being the most important thing, because you have to go back and learn these things. You know, it's just what it's part of. Like, like CAD. Okay, so like in the case of like CAD, you know, again, that one was just, I downloaded like Google SketchUp because it was free at the time. You know, it still is. But you download Google SketchUp, watch a video or two, tinker around with it. I'm not condoning pirating, but if you happen to have found yourself a copy of something, you know, tinker around with it.
If you happen to have unrestricted physical access to school systems.
Right.
you have
If you're still in
copies of it.
school and you have all this stuff, there's no reason that you shouldn't be at least playing around with it. Elliot.
So either in the context of one project or across multiple projects, as you've sort of been over the past couple of months and years.
Mhm.
I know that for me personally, when I'm working on a project and I'm working on different parts of a project, I like to, you know, I'm a perfectionist where I like to make one part perfect before I move on to the next thing.
Mhm.
Abandon that notion.
Yeah.
Well, right. I know that obviously in the context of, you know, something, you know, like senior design, which I'm coming up to now, you know, obviously I have a lot to do and not necessarily a lot of time.
Right.
And so, you know, obviously you've, you know, gone from project A to project B to project C, and obviously you've gone through the senior design process. So how do you know that something is quote unquote good enough to move on to the next thing? Because I hate leaving something as good enough, because good enough is never good enough.
Usually the way that I go about it is if it works, I move on. I can make it pretty later, right? So like if it's like a UI thing, or if it's like a, you know, the overall appearance of a circuit or something like that, I'll deal with that later. But if it does the, you know, like what I intended it to do function wise, like that's it. it's stored until I come back around for like a second swoop on things. So, in the case of like you have some function that, works for most cases and, bugs out under one condition. Forget it. Come back to it. Figure out the bug later. As long as it's mostly working, I guess my general rule of thumb is if it's like 75% plus, you can move on to the next part, come back around for the last 25% later. And more often than not, you spend most of your time on that last 25%, right? I mean, I'm very similar with like, once I'm done with a project, I like to go back and like, tweak and tinker it over and over and over again until I have exactly what I had in my mind, it's like physical. But more often than not, it doesn't happen like that the first time around. So just move on, come back to it later. Another thing that I find very helpful is like if I'm stuck on something, moving on to another portion of the project sometimes allows me to just get it off my mind. And when I do come back to it, I come back with kind of a fresh take on it. And that really helps kind of push me forward. Like with for example, like the skateboard project. It was great, for most of the part with the, with the motor and everything. But when I got to kind of the Bluetooth interaction between the glove and the actual motor piece, I got stuck on like one little piece of it where, I could turn the motor on and off, but when I adjusted the speed, it would speed up and then it would slow down immediately after I would stop speeding it up. If that makes sense. So like as I was turning the speed up, it would ramp up its speed. But as soon as I stopped continuously turning the speed up, it would just drop back down to minimum. Right. And I was very frustrated with this because I couldn't figure out why this was happening. Right. I was like, you know what? It's all right. I have the communication going both ways. I've gotten motor turning on. I've gotten motor going a certain speed. I'll come back to this in a second. Right. And then I went over and I worked on the motor for a bit. And I worked on kind of the casings and I worked on all that stuff. And when I came back later that day, I realized, oh, wait, like very first line of, this while loop that I had inside was setting my speed back to 0, as just like my, initializing it. And I was like, oh, I just have to like put this outside of the while loop. And all of a sudden, everything worked exactly like I had imagined it. But sometimes you just stare at things for too long that you can't really figure out what's going on. So let's see. I think Justin asked about flowcharts a second ago.
Yeah.
So with flowcharts, more often than not, what I do is I just like jot down notes on a piece of paper. Like, oh, I want it to do this. I want it to do that. I want it to be able to do this. And then once I kind of figure out the different, parts of the project, I then break those down individually. If I'm making like a really nice looking flowchart, I don't have like a particular software. I like that one that you saw, I like use like Google Drive, it was just like it was a drawing, but it was, again, after I'd gone through the handwritten version of it. So I guess flowchart wise, it's just whatever I, draw by hand. Emma asked, do I always work on projects alone? How do I collaborate with people post-college since we're not all in the same building?
On YouTube live streams.
On YouTube live streams. No, sometimes I work on projects alone, sometimes I don't. So like right now I'm working on one project for this one doctor in Nashville. And basically the design portion of it, I work on alone. And then I come to him, and say, is this what you had thought? And I get feedback from him. In terms of working on projects with, multiple people, at this point in time, I'm not really doing much of that. The last time I really did that was like senior design. I was working with Dan Catan and Ben Horlick. We just broke the project up into different parts. Like Ben kind of took on the biomed side, I took on the electrical side, and Dan took on, the comp sci-ish side of it all. In terms of collaborating with colleagues, you guys have phones, use them. It's not hard to like just call up something. Like when I yeah, well, I mean, no, but in all seriousness, like when I first started tweaking with the idea of like making PCBs for myself, I mean, I literally I spent probably 2-3 hours in a Google Hangout with Dan Catan as he kind of just like walked me through stuff that he had been doing for the past couple months, because I never worked with him before, and I was like, teach me the ways, and he did, and now I do that regularly. But that's probably the the whole thing. Let's see.
I don't know if there's were there any other questions that I missed?
I got a question.
Yeah.
When doing electronics projects, how do you make sure that you don't kill yourself?
Oh, this is a great one. I usually have my grandmother in the room when I'm turning things on, and I say, if I die, or like if I get shocked, call an ambulance. It's kind of my go-to.
For those of us that don't live with their grandma.
Right. For those of you that don't, if you're doing something with like high power, find someone before you turn it on for the first time. General rule of thumb is if you're doing electronics, put one of your hands in your pocket and the other one to turn things on and off. The idea being that if you short something, it's just across your hand and not across your body, right? So that way you don't blow out your heart.
Which would suck.
Which would totally suck. If you're working with like fire and fire type things, generally what I do is always have some sort of like exhaust with me, whether it be not exhaust, whether it's some extinguisher or something with me, whether it be like water or an actual like fire extinguisher, type deal.
Do you often work with fire?
I've been working a lot with fire more recently.
Okay.
I saw this really awesome video maybe like 2-3 weeks ago on like an induction forge. I was like, I need to make one. So
I saw that.
So that's what I've been tinkering with recently, which is pretty cool. It's like, but it's anywhere between 100 and 200 amps. It's only like 3 to 4 volts, but it's still just like an absurd amount of power to be tinkering around with just like by myself, in my backyard. So I always have like, when it goes on, I have like the cousin or like my grandmother, someone out there with me, just like make sure I don't kill myself.
Ben really wanted to talk about the concept of minimum viable product.
Minimum viable product. Yeah. So, I mean, when I'm doing like prototyping, usually the idea is get it working. Once it's working, I then go back and kind of go through iterations of
Justin Lee.
what is.
Like Justin's next one.
I think my comments are significantly delayed.
At Duke, there's apparently another Justin Lee grad student who cut his hand doing something his entire lab told him not to. Then this Justin Lee got people coming up to him telling them that he was an idiot. Emma was like, "Oh, that's awful, but kind of funny."
So the last I have is talk of Elliot as MVP. That's where I'm at.
Yeah.
I think I'm pretty far behind. But in terms of like minimum viable product, it really depends on like if I plan on taking something to be commercial or not. I will go through and look at how much of a discount I can get from certain places for placing large orders versus small. Like if you look at PCB design from like Osh Park or something like that, it's something like $5 for 3 boards of an inch, an inch squared. But if you order like $150 worth, the price drops from $166 a square inch to $1 a square inch. So you kind of learn what places have like deals, I guess, for different things. DigiKey's pretty good about it too. Usually, if you order like different increments, like if you order like 5, 10, 25, and so on and so forth, you get lower and lower prices. But then again, it goes back to kind of researching the parts, where I may have found something that was kind of like the exact part that I needed early on, and now that I've finished the project, I realized, oh wait, I didn't really need that one specific part. I could have gotten away with X op amp or this relay or whatever it may be, which is 10 times cheaper, but it's a little crappier, but it's 10 times cheaper. So.
Emma suggests that you need to build the burning octopus from Burning Man.
Yes. I don't know. Maybe. Let's do it. I got another couple days in DC. You guys want to do it? Let's see. I'm just gonna like move over here with the computer.
Yeah.
This way I can kind of see these comments a little bit faster. Get this there-ish. Okay, let's see.
Is this still on Periscope?
Is that still streaming too?
Yeah.
Is
Oh,
anyone
I've been
watching?
watching it.
Oh
Has
yeah.
anyone been
On the other
commenting?
angle.
Can you comment on
No,
that?
there's 0 people on it right now.
Well, what is it now?
Oh, Justin asked me if the ECG monitor was the one we did in case of. No, it was not. So this was actually for a different project that I did for Kay when I was working in his lab. So Kay does a lot of cardioelectrophysiology stuff. And while I was working for him, they were doing working heart studies. And one of the things that they wanted to look at was variability. So I did that for them.
Can we stream everything? Yes.
This
Yeah.
is fun.
Yes.
It's fun.
Every meeting.
Every meeting is just gonna be streamed from now on.
But other than that, guys, I don't really have anything else to say. You guys have any more
How
questions?
much practice does it take doing like electrical kind of projects before you feel like, oh, I got the hang of it?
That's a question.
Here, what's going on?
What isn't going on with my hair? What's going on?
Yeah. In terms of electrical design and feeling comfortable, that's my secret. I never feel comfortable. It's you kind of just wing it and pray that it works. You hope that you don't see the magic smoke.
Yeah. No, so I've also heard that the secret to electrical engineering is that all electronics that are contained in a box have magical smoke in it. That is what actually makes
The reason they
Yeah,
call
sure,
it
sure.
a black box when
Right.
you're talking about prototype because it's literally black magic.
okay.
You just throw some parts in there. And
Literally.
You pray.
You put everything in the right orientation so that the electrons don't fall out.
Right. it's like a series of shoes.
Okay.
You always want to minimize your rotational velocity density.
I don't know what that means.
Exactly.
Exactly.
That's the beauty of electrical.
Embed Brandon's hair with LEDs.
I think that's actually
I think we can do that. Yeah.
Some of that conductive thread.
Or LEDs that respond to Elliot's laugh.
Wait, LED sign
Yeah,
just
if
says-
you're curious,
LEDs.
one of the like I think it was the second generation of the all.
It was the
Lights
headband
project.
one.
Yeah, when we made the headbands, they would respond to Elliot's laughter.
Literally, I remember
Right,
asking
because
him-
it was based
Well,
on-
no. It was
Right.
literally because you made the first prototype with the microphone. We were walking out of Tompkins, and I was just talking.
Yeah,
to
he was
you,
just talking to me.
and the lights were just flashing.
And it wouldn't do that for anybody else.
Just Elliot.
I was doing the LED stuff.
I like that I'm delayed.
Right. It happens. What do you think I've got in there?
Boom. Innovation. Love it.
Mm.
It was like watching
Yeah.
what happened a minute ago.
What is it?
I was waiting for them to
Educate,
do more
innovate,
comments.
create.
What?
Educate, innovate, create.
Yeah. Hands in, guys.
Educate.
Educate, innovate, create.
Woo!
Whoa.
We're supposed to do more than one. Elliot.
Elliot, you haven't been to the last few meetings where we've talked about the culture.
We do it every board meeting, Elliot.
Right. So yeah,
Right.
that's actually important. We're now a cult here at Tech
Yeah.
Collective.
Yeah.
We finally made the transition.
Good to know.
We have a chant.
Yeah, we've got a chance.
It's official.
We're gonna have some songs.
Well,
I feel.
luckily for me, I am no longer on the roster, so.
Oh.
Luckily.
You see,
I've
that's the thing.
disappeared, number and all.
You never exit the roster.
I never existed.
Wait.
There goes the Periscope.
Spider.
They suddenly see the ceiling.
You want to wrap this up?
Yeah, I think it's time to call it. Beautiful people that were streaming, I love you all so much. You guys should come visit me in Nashville. I will definitely try and make my rounds to see all you. I'll make a trip out to Cali at some point and visit Emma and Dan. Yarmus, I'm gonna make a trip up to visit Chris at some point, so I'll see you then.
Not for you.
No.
No. Like I'll be in New York. It's
But
like
I'll
a
be
New York,
around.
I'll be around.
New York, you know. Who else was on there? Justin, are you still in DC? No, you're at Duke. One of Dan's old roommate, Jeremy Alulian's going to law school down there. So just so you know, in case.
So
you're,
I'll also go visit this other person
Right.
and just.
And
No,
you'll be there too.
It's not about visiting other people. It's just letting you know there's more people coming. Anyway,
Still
Thanks,
coming to
guys.
visit you.
Bye.
All right, it's
Oh,
my
it's-
turn. Well, like I don't know what it was.
Stop.
Wait.
Yeah.
Great.